I will be conducting two experiments in this video. The first is surface tension between water and objects in water versus another substance like alcohol. In this bowl here I have water, my Aquafina water, and in this one I have 91% alcohol. Now I use these hairbands that I found which worked very well for this. They're teletized, beautiful for your hair, but we aren't even going to get into that today. So if I place it gently on the water, it does not break the tension of the water. But if I put it in the alcohol, same exact way, very gentle, it sinks immediately. This is because the alcohol has no surface tension. The hydrogen bonds in the water create a molecular net that does not break if something can be put on it very gently. Like in the video we saw a paperclip. This is called surface tension. And the surface tension of a water can hold up things that are denser than water because of its molecular net. Now, if we focus our attention to what I have behind here, we are going to be talking about capillary action, which, as you can see, I have a bowl of pink water and a bowl of blue water. I put a very narrow piece of paper in here, which is the same height as this paper, but since it's more narrow, it is sucking up more water, so it's starting to fold and bend, versus the more wider one that started to unfold and is not sucking up the water. We call this sucking up the water adhesion. The more narrow your object in the water is, the more adhesion it's going to have and the more water is going to be retained in it. This is because the paper is polar and the polar molecules in the water are attracted to it, so it's getting more of that water actually. And this is what we call capillary action because it resembles the capillary vessels in our hearts and things like that. And those are the two experiments I have for you today, and I hope you learned something from them.